Yeah.
Yes, sir.
We've looked at how to perform basic plots, and we said when you use the plot function, the plot is rendered as data points, isn't it? But if you want to make it a line graph, what do? If you want to make it a line graph, you have to supply in this second parameter type, isn't it, to be L? And then at that point it would, and when you use only one parameter, it will use both the, if you use one parameter here, it will take it as both the x and the y axis, isn't it? In a symmetric way. So when when x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3, like that. However you put it, even if it is 2, 4, 6, 8, and you only supply one parameter, so to assume that the value of x and y are the same. But in the more natural way is for you to supply in both the x and the y axis. And that's what we have here. You can supply in both the x and the y axis. And in that way, where is it? Yeah, here, isn't it? You can supply in both x and y axis, isn't it? But at this point, it will not make sense for you to, when the graph is like this, even if you make it to be a line graph, it will not make any sense. You have all sort of zigzag, funny looking plots, isn't it? And we said RStudio is not the only way of rendering R codes. You can run R codes in a plethora of other methods, isn't it? So while RStudio provides the graphics pane for you to see your graphs, isn't it? It may not be available in other methods, isn't it? So one natural way is just for you to use some of these methods. Code. You open a graphics device using any of the following methods, either as a PNG, JPEG, or PDF, isn't it? And then, of course, after writing your code, you have to close it, dev.off. If not, if you don't do that, then even if you run another code, you will not see the plot, isn't it? It will just be coming out as error. We looked at that yesterday. You can plot multiple lines in one plot. It's just for you to plot the first one, and then the second one, you simply use the lines function, isn't it? Then you can supply in different parameters such as color and what have you. We've seen how to do bar charts. Also seen how to do, so we'll start from here today, pie charts. This is also a very popular way of presenting data, isn't it? Especially when you, it's very natural that you present pie charts of several things. Maybe it's scores, and there are male and female applicants, and you want to know the percentage of female that passed, isn't it? Or the percentage of male that passed, or the percentage of 400 level students that passed, or the percentage of people that got A, or the percentage of people that got B, or the percentage of people that got C, etc., isn't it? So this is how you do that. And the function is simple. It's pi, P-I-E. So you have in your x-axis, and then you have in your y-axis, isn't it? Your x-axis, sorry, in the pi there's something like y-axis, isn't it? Because it's just a pie chart. I think we all know how to compute pie charts now, mathematically. If you have to find the pie chart of this 8, 10, 42, 14, what will happen? You see 8 divided by the total multiplied by 360, because the total angle in the cycle is 360. Of course, you want to, if you do for this, and this, you want to label them. So this is the labeling also as a vector. So you simply call pi the vector or the original vector, and then the label, isn't it? So this is an example. Let's use the empty cars data set to build a real pie chart showing some data insights. So let's create a pie chart for the average horsepower for each gear group. So for each gear group, we want to get the average horsepower, isn't it? So what do we do first? So it means we are going to have three numbers, isn't it? We are going to have three numbers, one for each gear group, isn't it? And how do we do that? You can do it the lazy way, right? Or I call it, it's not even the lazy way. Should it be? Because the lazy way is the smartest way, actually, isn't it? You can do it the dull way. Where you have to order them by each gear from the entire data frame. You order them by each gear, and then you take the horsepower column, and then you take the average So for the second gear group, for the third, and then you come and get a vector containing the average gear for gear 1, gear 2, gear 3, and then you come and do your pie chart, isn't it? But of course you have your this, we talked about by earlier, isn't it? But if you want it to be rendered as a vector, the t apply and the by do the same thing. Sure, you record by now? The by function, by, which orders a particular, computes this, ordered by this, sorry, it computes this on this, ordered by what? By this, isn't it? If you do empty cars HP gear, you see article. Okay. If you do by empty cars, so I want to compute the HP isn't it? Ordered by what? Empty cars ordered by, I want to compute the mean of the horsepower of each car ordered by gear Gear is G and then want to compute the mean, isn't it? If you print this, what do you have? It's clear now. It's all right. Prof, this is clear.
It's not yet.
Who didn't understand this? Okay, who understood this, what I did? If you understood what I did, please let me see your hand. Nobody understood this? Empty cars, Nagashiba? If I want to get the average horsepower of the cars, every car here has a horsepower, isn't it? Every car has a horsepower. If I want to get the average horsepower, it will be simply mean of what? Empty cars, $HP, isn't it? And that will give me 146 points. This is the average horsepower of all the cars in the empty cars data set. isn't it?
Yes.
Now, I now said it is not fair. Please, let's pay attention. We are now saying it is not fair for you to calculate the average horsepower of the cars, having in mind that some cars are gear 3, some cars are gear 4, and some cars are gear what? Are gear 5, isn't it? We now said one way is for us to be able to what? We can get all the cars that have gear 3, isn't it? We can have a data from this empty car, from empty cars, isn't it? If I want, how many are they? If I want to get the number of rows, how many entries are they? You can do dim, go? Dim empty cars, isn't it? It will tell you that there are 32 rows and 11 columns, isn't it? How can you? Yeah, I'm not happy. It's as if I'm going. Check. It's clear number. But these 32 cars, some of them have gear what? Some of them have gear 4, some gear 3, and some gear 5, isn't it? I now want to extract only the data frame of cars that have gear 3, isn't it? I can say okay, I can say gear 3 should be equals to what? If I want to extract only the cars that have gear 3, that will be what? Empty cars. Empty cars. No, I'm extracting my empty cars now. So empty cars, empty cars, dollar sign, gear, not comma 3, equals to 3, equals to 3, comma, isn't it? This will give me gear, all the cars that have gear 3, isn't it? Isn't it? Nakashiba? Only gear 3 we have here, Isn't it? How can it? If you do dim gear 3, you see, gear 3, there are what? There are only 15 cars that have gear 3. If I want to do gear 4, it will be what? The same thing, Gear 4, isn't it? If I do gear 4, I will see only gear 4, isn't it? Is that okay? And then if I want to do gear 5, it will be what? Gear 5. Gear 5. And if I do gear 5 now, I will see only gear 5, isn't it? Is that correct? So I have only cars that have gear 3 in the data frame gear 3. I have all the cars that have gear 4 in empty car in gear 4 and gear 5. Now if I want to compute the average horsepower of gear 3 cars, what will happen? Just gear 3 gear 3, okay, mean of gear 3 dollar sign what? HP, isn't it? This will give me the average horsepower of what? Of cars that have 3 gears. If I want to find the mean of gear 4, it will be what? 89.5. If I want to get the average horsepower of gear 5, it will be what? Gear 5, 176, 89, 195. Synergy. This thing that I did now, we can do it in one line of code. Using what? Using by. And by needs 3 things. The first thing is what? The last one, the function that I'm applying, let's say mean. Sai kuma the second one is the order in which we want to split the original data ko is by what? By gear. We now say to empty cars, what? Dollar sign, gear ko. And then idan muka rarraba su by gear, we want to now calculate the mean of what? Of the horsepower. Then we now have empty cars, dollar sign, HP. So this line, wannan code din da muka yi yanzu, is the same thing as all those abin da muka ta in. Zai ba mu 176, 89 and what? And 195. Prof, is this clear?
I'm clear.
Okay.
Do you know what the problem is?
No.
To cram all this formulation and function.
No, it's not allowed. It's allowed for you to have a cheat sheet beside you. The most important thing is for you to know the concept. Nobody says you have to memorize all the syntax. But the most important thing is that if you see by, you know what's happening. You know, okay, the first thing is what we want to apply on. The second thing is what we want to split by. And then the third thing is the function we want to apply on, isn't it? Nobody says you have to cram that, isn't it?
What I'm saying is this. Is that all the function that we are applying? By the time you come to, as we are here, you have to pick from somewhere what you did before and apply part of it here to get the real.
So you can imagine if we didn't even lay the foundation. Now we have laid the foundation, but we are finding it difficult to even relate the foundation that we've laid. So you can imagine if we just started going Kaita and I just say apply dollar sign. I don't even know what dollar sign is. And that's why we said whatever we learn, those nitty-gritty from week 1, week 2, week 3, they are all important in getting whatever you want to do ready.
But this is, to me, I don't know that. This is, it needs constant practice.
Yes.
So that you can get used to it.
Yes, you're right.
At the end of the day, you can be able to apply it wherever you want to apply it.
Yes. Yes.
Get the answer.
You're right.
So that's why when you ask questions, for difficult to answer because you think where to bring that one and put it here. This is why at this particular time. Thank you.
Thank you, Prof. So, but what do you notice now? What do you notice now? If you do buy, and then, please, this is very important. If you do buy, what happens? It gave us the. It gave us. This is distracting us. It gave us 176, 89, and 19. Is this one a vector?
Yes.
Is this a vector?
It's a vector.
No, it's not a vector, Prof.
So, wrong.
One vector ni? It's not a vector. Misali vector yake. Vector is something that is let's say C to maybe 176 point C 176 89 cool? And then what? 199.6 cool? Isn't it? This a vector, I go. A vector is just in 1, 2, 3 go. And sheet pie chart requires you to supply in a vector, isn't it? Isn't it? So even though the buy is giving us what we wanted, but it is not giving us the answer as a vector. If you check the formula, it says pi, let me go back to the first one, pi x and then the what? The label, isn't it? So x is a vector, but this guy is not a vector. So shine aka kawo t apply, okay? T apply, isn't it? does exactly the same thing as by. Amma shi me yakon ya baka ansan a wannan layi din, it will only give you the raw answers as what? As vectors. For example, if you do by now, you have this, right? But if you do t apply, sorry. If you do t apply, what do you have? You have a vector, isn't it? 3 having this, 4 having this, and 5 having this. So that's why you can apply it to the pi function. Is it clear now?
Yes.
So now we can do t apply to get x, go, and then from the t apply you see that there are two things, go. Akwai label din sai kuma the actual value, go. You saw 3, 4, 5. So you can even get the label from the t apply using the function names. Okay? Okay? Here. If you this t apply, go, if you call this x, for example, huh? This t apply that we did now, if you call it now, if you do names of x, go, it will give you what? 3, 4, and what? And 5, isn't it? So that's why you can now come and apply the x, which is the t apply. The label should not be the whatever you put here. Go label, then the labels, isn't it? Then of course the main function that for the name of the function, something like that. But this one should not have x label and y label because there's no x and. So in that case, if we call the, let me call this one to be label, isn't it? So if you do pi of what? X label and then main is equals to what? Pie chart. Pie chart is the one word. Pie chart showing HP of HP by car gear, isn't it? So if you do that, you see that the pie chart is going to be rendered to you here, isn't it? Five, 10 apples. 10 apples were shared amongst Aminu, Amina, and Ahmad. Aminu was given 6, Amina 2, and the remainder to plot a pie chart go showing how the apples were shared amongst this tribe. Is that? Is that? Eh. So, Angani, who has finished? No, it's a classwork for you to. So it will be what? We have the first thing is to have a vector containing their share scope. Let's say share scope. The share should be what? It's a vector. The first one is amino having what? 6 scope. Amina, and then the remainder would be 10 minus open bracket. You want to be mathematical? 6 plus 2 go, isn't it? Isn't it? And then I can say the names go are what? Aminu, Amina, and then Ahmad, isn't it? That's it. Pi, go. Showing what? The first one is the vector containing the values, go. That's share, go. The second one is what? The label, go. Label is equals to what? Names, go. And then the mean is what? Go. Is the what? Plot of pie chart, go. Plot of pie chart, go. Pie chart, go. Pie chart. Pie chart, isn't it? Good. We shall go. Now, if you run this, what happens? What do you have? Who has the largest share? Aminu, isn't it? And then Amina, and then Ahmadu, isn't it? It's clear now. So note that we used tapply function to Sorry, are you done? Yes. Okay. So notice that we use the tapply function to group the data by gear column and then apply the mean function on the HP column. We take the labels using the names function and then use it for our pie chart. As the result of tapply is an array, we can simply pass it to the pie function as the pie value. That's why we cannot use the by function. Now let's look at box plots and histograms. Box plot is also another very important. So, box plot. A box plot shows how distributed the data is, isn't it? If you want to see a very horrid look at the distribution of a data, you can use a what? A box plot, isn't it? What can you see from a box plot?
How parameters?
What parameters? What statistical parameter can you? If I give you a data and you plot the box plot, what can you see from there? Misali yanzu empty cast MPG go, empty cast box plot empty cast MPG. Let's say box plot empty cast $ MPG, isn't it? Shiva? Alaikum salam. If you do summary of this guy, what do you have? The minimum value. You know, if you just print it, what do you have? This is it, what? What's the mean? The mean is 20.09, isn't it? And then the minimum value is what? The minimum value here, the mean here, is 10.4, and then the maximum value. So look at, if you do the summary, it gives you everything. It gives you the mean, the first quartile, the median, the mean, the third quartile, and the max. So also if you do the box plot, of anything, and it's going to give you a plot that is showing that kind of behavior, isn't it? Yes. So from the box plot, you should be able to know that the median is around here, isn't it? One is the median is around 19 point something. Was that what you got? It's around the median. If you do the summary, 19. The median is around 19.2. The maximum value, shine one number. 33 point something. And then the minimum value was 10.4. So you can see 10 point something, isn't it? And then this is the third quartile, isn't it? 15 point something. And then first quartile. First quartile shine Kasa median number between the minimum and the median. Shikumo third quartile is between the median and the maximum. So the third quartile is what? 22.80, isn't it? There's another one. There's what they call interquartile range, isn't it? How do you calculate it? Q3 minus Q1 over. Yeah? Okay. Q3 minus Q1 over Q something. Yeah, so you can, from there you can be able to get that correctly, isn't it? I used to be a fan of statistics when I was in. No. Okay. Isn't it? So a histogram represents the frequencies of Okay? The histogram, the bar chart, they look somewhat the same, huh? But what's the difference? They do different things. One way they are AK, they are AK. One is primary school, is primary school the description. Bar chart ko is okay, one level. It carries every individual. A bar chart in the chain mark a bar chart in the check a bar chart 2 4 5 6 2 8 bar chart ba is it for that can check 2 go this is 0 0 1 2 3 4 5 go ama sorry you not do that one number for 2 that can 2 the go kowanne is a number on its own. A zai zama 2 go, B zai zama 4, maybe this is 2 4 5 zai zama maybe kuma shine C go, wannan kuma D zai zama 6, nan 2 ga wani although mun yi 2 amma wannan zai zama E go, sai kuma shi ma daidai 2 din shi. So this is bar chart, but histogram, it carries every unique value and checks how many times does it appear, isn't it? So one, how many times does one appear here, isn't it? Then you plot it, isn't it? Or if you have A, B, C, D, E, F, let's say you have A, B, C, A, B, A, B. So A, how many times? You count it. A is 2 times. You can never see A again. B, how many times? Okay, 4 times, 3 times, 1 time, etc. So, a histogram represents the frequencies of values bucketed into ranges. It is similar to a bar chart but groups the values into continuous ranges. The hist function is used to create a histogram. So let's make one for the HP column in empty cars. So it will be what? It will be hist. Hist what? Empty cars. Empty cars, dollar sign HP. If you do that, you should get something like this. Go. So the ranges of buckets are automatically set based on the data, isn't it? So let's look at some basic plotting functions. So you can have something like this. Go. This one, you have x is what? Is a vector of 1 to 10. And you say y is what? X raised to the power of what? 2, isn't it? If you plot this, it should be something like what? Quadratic. Quadratic. How is quadratic? How? Yeah, quadratic. Maybe if you say let me say x is x is 1 to 10. Go. X is 1 to 10, and then y is x raised to the power of 2. Go. And then you want to plot x comma y, isn't it? Let me just ignore the other things. Go. So it should be what? It should be 8 comma. I say it well. 8 comma 1. So So you can do histograms and then some other. So these are how we do basic plots, isn't it? In R. But like we mentioned, there are more advanced tools that whatever we've been learning, all these empty cars, $sign, HP equals to kaza, YY, wannan shine base R. Shine base R. When the designers of R designed R, that was how they designed it to be manipulating data. But some people now said, I don't know how you can do it in a more fun way, isn't it? And they now began developing several modules that will make life easier, isn't it? Just like in your normal computing paradigm, Windows came with CSV, isn't it? You now said, to Excel when I put color, bolding in. It came with Notepad. Microsoft Word, when typing documents, so Sumaka, people came and designed several tools that would make life easier, and that is what we'll look at now. We'll look at this, a very popular one called tidyverse.